Using quartz lamps and high-intensity discharge systems for emergency lighting requires careful consideration. High-intensity discharge systems need ballast to ignite the lamps, which can increase the electrical load and reduce battery life. Quartz lamps are not typically designed for high-intensity discharge applications and may have shorter lifespans in this context. To maintain 1-foot candle illuminance, 7 to 100 watts quartz lamps would require a significant amount of power, potentially limiting battery runtime. Alternative solutions should be considered. LED emergency lighting fixtures consume less power and have a longer lifespan than quartz lamps, making them a more suitable choice for emergency lighting systems that require long battery life. Incandescent emergency lighting fixtures with emergency bulbs are specifically designed for emergency lighting applications and have a longer lifespan than standard incandescent bulbs. Potential problems exist when using quartz lamps. Bulb failure is more likely with quartz lamps than with high-intensity discharge or LED lamps, which could compromise the emergency lighting system. High-intensity discharge systems can generate electromagnetic interference that may affect other electrical devices. The high wattage of quartz lamps can generate excessive heat, which may damage the emergency lighting fixture or surrounding components. If quartz lamps are still deemed necessary, consider using manufacturers that specialize in high-intensity discharge systems for emergency lighting. Some reputable brands include Quartz, GE Lighting, and Hubbell Lighting. Additional advice includes: firstly, conduct a detailed calculation to determine the exact wattage and number of lamps required to achieve 1-foot candle illuminance. Secondly, consult with a lighting expert. A qualified lighting engineer can provide guidance on the best lighting solution for specific requirements. Thirdly, test the system thoroughly. Conduct rigorous testing to ensure the emergency lighting system meets the required runtime and illumination levels. Consider the power consumption of the system. Calculate the total wattage required for the quartz lamps and the ballast, and then determine the required battery capacity to provide at least 90 minutes of emergency lighting. The battery capacity should be sized to account for voltage drop and temperature variations. Evaluate the ballast compatibility. Ensure that the ballast is compatible with the quartz lamps and the emergency lighting system. The ballast should be designed for emergency lighting applications and should provide a stable output voltage and current. Check the lamp lifespan and replacement costs. Quartz lamps have a shorter lifespan than high-intensity discharge or LED lamps, which can increase the overall cost of the emergency lighting system. The replacement cost should be factored into the overall cost analysis. Assess the heat dissipation requirements. Quartz lamps generate a significant amount of heat, which can damage the emergency lighting fixture or surrounding components. The fixture should be designed to dissipate heat effectively and should be installed in a well-ventilated area. Consider the electromagnetic interference. High-intensity discharge systems can generate electromagnetic interference that may affect other electrical devices. The emergency lighting system should be installed at a location that is away from sensitive electronic equipment. Review local codes and regulations. Ensure that the emergency lighting system meets all applicable local codes and regulations. The system should be inspected and approved by a qualified electrical inspector. Conduct regular maintenance. Perform regular maintenance on the emergency lighting system to ensure that it is functioning properly. This includes testing the system monthly and replacing the batteries and lamps as needed. Explore the use of a hybrid system that combines quartz lamps with LED lighting. This could provide the desired illuminance while reducing power consumption and extending battery life. For example, use quartz lamps for general illumination and LED lighting for task lighting. Consider using a dimming system to reduce the power consumption of the quartz lamps during normal operation. This can extend the lifespan of the lamps and reduce the overall energy consumption of the system. Ensure that the dimming system is compatible with the emergency lighting system and that it does not compromise the system's performance during an emergency. Evaluate the use of a central battery system to power the emergency lighting system. This can provide a more reliable and cost-effective solution than individual battery packs for each fixture. The central battery system should be sized to meet the power requirements of all emergency lighting fixtures and should be maintained regularly. Investigate the availability of quartz lamps that are specifically designed for emergency lighting applications. These lamps may have a longer lifespan and better performance than standard quartz lamps. Check with lamp manufacturers for product specifications and availability. Consider using a lighting control system to manage the emergency lighting system. This can provide features such as automatic testing, remote monitoring, and energy management. The lighting control system should be compatible with the emergency lighting system and should be programmed to meet specific requirements. Review the emergency lighting system design with a qualified fire protection engineer. This can help ensure that the system meets all applicable fire safety codes and regulations. The fire protection engineer can also provide guidance on the best location for emergency lighting fixtures and the required luminance levels. Investigate the use of wireless emergency lighting systems. These systems can be easier to install and maintain than traditional wired systems. The wireless system should be reliable and should have a backup power source in case of a power outage. Consider using a generator to provide backup power for the emergency lighting system. This can ensure that the system will continue to operate even during a prolonged power outage. A generator should be sized to meet the power requirements of all emergency lighting fixtures and other critical loads. Evaluate the use of a smart emergency lighting system that can adjust the illuminance levels based on occupancy and ambient light levels. This can save energy and extend the lifespan of the lamps. The smart system should be reliable and should have a backup power source in case of a power outage. Consider the color rendering index requirements for the emergency lighting system. The color rendering index measures the ability of a light source to accurately render the colors of objects. For some applications, it is important to use a light source with a high color rendering index so that people can easily identify objects and hazards. Ensure that the emergency lighting system is properly grounded to prevent electrical shock hazards. The grounding system should be installed in accordance with all applicable codes and regulations. Consider the glare from the emergency lighting fixtures. Glare can reduce visibility and cause eye strain. The fixtures should be designed to minimize glare and should be installed in locations where they will not cause a problem. Evaluate the use of a self-testing emergency lighting system. These systems automatically test themselves on a regular basis and alert the user if there is a problem. This can help ensure that the system is always functioning properly and that it will be ready to operate in an emergency. Investigate the availability of emergency lighting fixtures that are designed to withstand harsh environment. These fixtures may be necessary for applications where the fixtures will be exposed to moisture, dust, or other contaminants. Consider the aesthetics of the emergency lighting fixtures. The fixtures should be chosen to complement the overall design of the building. The fixtures should also be unobtrusive and should not detract from the building's appearance. Evaluate the use of a networked emergency lighting system that can be monitored and controlled remotely. This can provide a centralized view of the system's status and allow the user to respond quickly to any problems. Investigate the availability of emergency lighting fixtures that are designed to be vandal resistant. These fixtures may be necessary for applications where the fixtures are likely to be tampered with or damaged. Consider the warranty for the emergency lighting fixtures. The warranty should cover defects in materials and workmanship and should be for a reasonable period of time. Evaluate the use of a leasing program for the emergency lighting system. This can help reduce the upfront cost of the system and provide ongoing maintenance and support. Investigate the availability of financing options for the emergency lighting system. This can help make the system more affordable and allow the user to spread the cost over time. Consider the total cost of ownership for the emergency lighting system. This includes the initial cost of the system as well as the ongoing costs of maintenance, energy, and replacement parts. Evaluate the use of a life cycle cost analysis to compare different emergency lighting systems. This can help the user choose the system that will provide the lowest total cost of ownership over the life of the system. Ensure that the emergency lighting system is properly documented. This includes providing detailed drawings, specifications, and operating instructions. The documentation should be readily available to maintenance personnel. Consider the training requirements for maintenance personnel. Maintenance personnel should be trained on how to properly operate and maintain the emergency lighting system. Investigate the availability of training programs for maintenance personnel. Consider the disposal requirements for the emergency lighting fixtures and batteries. The fixtures and batteries should be disposed of in accordance with all applicable codes and regulations. Evaluate the use of a recycling program for the emergency lighting fixtures and batteries. Review Underwriters Laboratories Standard 924, the standard for emergency lighting and power equipment. This standard covers the requirements for emergency lighting and power equipment, including battery-operated emergency lights, exit signs, and central battery systems. The standard specifies the performance requirements for these products, including the minimum illumination levels, battery runtimes, and environmental conditions. IL 924 also includes requirements for the construction and testing of emergency lighting and power equipment. Consider National Fire Protection Association 101, the Life Safety Code. This code provides requirements for emergency lighting in buildings. The code specifies the minimum illumination levels, battery runtimes, and location requirements for emergency lighting. It also includes requirements for the inspection, testing, and maintenance of emergency lighting systems. Review the International Building Code. This code contains requirements for emergency lighting in buildings. The code specifies the minimum illumination levels, battery runtimes, and location requirements for emergency lighting. It also includes requirements for the inspection, testing, and maintenance of emergency lighting systems. Ensure compliance with Occupational Safety and Health Administration regulations. Occupational Safety and Health Administration regulations require employers to provide a safe workplace for their employees. This includes providing adequate emergency lighting in buildings. Occupational Safety and Health Administration regulations also include requirements for the inspection, testing, and maintenance of emergency lighting systems. Consider the Americans with Disabilities Act Accessibility Guidelines. The Americans with Disabilities Act accessibility guidelines require that buildings be accessible to people with disabilities. This includes providing adequate emergency lighting for people with disabilities. The Americans with Disabilities Act accessibility guidelines also include requirements for the location and illumination levels of emergency lighting. Ensure compliance with state and local building codes. State and local building codes may have additional requirements for emergency lighting. It is important to check with the local building department to ensure compliance with all applicable codes. Consider the specific needs of the building and its occupants. The emergency lighting system should be designed to meet the specific needs of the building and its occupants. This includes considering the size and layout of the building, the type of occupancy, and the presence of any hazardous materials. Evaluate the risks associated with a power outage. The emergency lighting system should be designed to mitigate the risks associated with a power outage. This includes considering the potential for fire, panic, and injury. Ensure that the emergency lighting system is properly installed and maintained. The emergency lighting system should be installed and maintained by qualified personnel. This will help ensure that the system is functioning properly and that it will be ready to operate in an emergency. Consider the use of a commissioning process to verify the performance of the emergency lighting system. The commissioning process should include testing the system under various conditions to ensure that it meets the design requirements. Evaluate the use of a building automation system to monitor and control the emergency lighting system. This can provide a centralized view of the system's status and allow the user to respond quickly to any problems. Consider the cost of the emergency lighting system. The emergency lighting system should be cost-effective while still meeting the required performance standards. A life cycle cost analysis can be used to compare different systems. Ensure proper battery maintenance. Batteries are a critical component of emergency lighting systems. Proper maintenance is essential to ensure that they function correctly when needed. Follow the manufacturer's recommendations for battery maintenance. This typically includes regular testing and replacement as needed. For sealed lead-acid batteries, check the terminal connections for corrosion and clean them as necessary. Ensure that the batteries are properly charged. Overcharging or undercharging can damage the batteries and shorten their lifespan. Replace batteries before they fail. Batteries should be replaced on a regular schedule, even if they appear to be functioning properly. This will help ensure that the emergency lighting system is always ready to operate. Use high-quality batteries. High-quality batteries will last longer and perform better than cheaper batteries. Choose batteries that are specifically designed for emergency lighting systems. Consider using a battery monitoring system. A battery monitoring system can provide real-time information about the status of the batteries. This can help identify problems early and prevent battery failures. Keep accurate records of battery maintenance. This will help track the performance of the batteries and identify any trends. Disposal of the old batteries in accordance with all applicable regulations. Consider the ambient temperature of the location where the emergency lighting system will be installed. High temperatures can shorten the lifespan of batteries and other components. If the system will be installed in a high-temperature environment, choose components that are designed to withstand high temperatures.